You ever stop and think about what's actually happening when you cook something? Or when you see a firework light up the night sky? It feels a little like magic, doesn't it? Well, it's actually science, and today we're going to pull back the curtain on these incredible and often invisible transformations that happen all around us. We're talking about chemical reactions.
So let's start with something we all know. You've got a raw piece of meat, you throw it on a hot grill, you hear that sizzle, you smell that amazing aroma, and a few minutes later, you've got a cooked steak. It looks different, it smells different, it definitely tastes different. But what actually happened to it?
And that's really the big question, isn't it? Are we just making it hot, kind of like melting an ice cube that we could easily freeze again? Or has something completely new been created here? Something that we can't change back? Well, that's exactly what we're here to figure out. Here's our game plan. First, we'll tackle the difference between a physical and a chemical change. Then, we'll define what a chemical reaction is. We'll learn how to spot the evidence of a reaction, find some examples in our daily lives, and then we'll wrap up with a quick quiz to test what you've learned.
Okay, first things first. To really get a handle on what chemical reactions are, we first need to understand what they're not. So let's draw a clear line between a physical change and a chemical change.
So look at the left side. A physical change is all about form. Think about ice melting. It goes from solid to liquid, but it's still just H2O, right? You can pop it back in the freezer and get ice again, no problem. But now, look at the right. A chemical change. When you burn wood, it turns into ash and smoke. You can't unburn it. You can't turn that ash back into a log. Why? Because a totally new substance has been made. And that's the key difference.
So whenever we see one of those chemical changes, like our burning wood or our cooking steak, the engine that's making it happen is something called a chemical reaction. Let's pop the hood and see how this thing actually works.
All right, here's the official science-y definition. A chemical reaction is a process where the original ingredients, which we call reactants, have their internal connections, their chemical bonds, broken. Then, a whole bunch of new connections are formed, creating totally new things, which we call products.
It's really like a three-step dance. First, the old bonds that hold everything together just snap. Second, all the little atoms get shuffled around into new positions. And finally, boom, new bonds form, locking the atoms into brand new arrangements. It's kind of like taking a Lego car, breaking it down to all the individual bricks, and then using those same bricks to build a spaceship.
And this visual just shows it perfectly. See on the left? Those are our starting molecules, the reactants. Then in the middle, you see their bonds breaking and all the atoms are just floating around, ready to mingle. And then on the right, those exact same atoms have linked up in a new way to form totally new product molecules. Nothing was lost. It was just rearranged.
Okay, so we can't actually see those little atoms breaking apart and rearranging. So how in the world do we know a reaction is even happening? Well, we have to be detectives. We have to look for the clues.
And here are the 4 big clues you need to be on the lookout for. A solid might suddenly appear out of nowhere. You could see a surprising change in color. Maybe you'll see bubbles of gas forming. Or you might see light or feel heat being given off. Let's see each of these clues in action. First up, the formation of a precipitate. This is so cool. You can take 2 liquids that are perfectly clear, mix them together, and bam! Instantly a cloudy, solid material appears. That solid is the totally new substance. That's a dead giveaway that a reaction just took place.
Clue number 2, a change in color. Now check this out. We put a piece of zinc into this bright blue liquid, and as the reaction happens, you can see the blue color literally disappearing. This isn't like adding water to paint to make it lighter. The actual chemical that was making it blue is being transformed into something else entirely.
Our third clue is the evolution of a gas. When this little strip of magnesium is dropped into acid, it starts fizzing like crazy. Those bubbles aren't because it's boiling. Oh no, that's hydrogen gas, a brand new substance being created right before your very eyes.
And finally, maybe the most dramatic clue of all, the emission of light or heat. I mean, you can't miss this one. When this magnesium ribbon burns, it releases an enormous amount of energy as this super bright, brilliant light. All that energy was locked away in its chemical bonds, and the reaction just set it free.
So now that you know the definition, and you know the clues to look for, you're going to start seeing chemical reactions absolutely everywhere. They're not just for some fancy science lab, they are a core part of our world.
And this just shows you the incredible range. On the left, cooking an egg is all about slow chemical reactions that turn the liquidy parts solid. And on the right, you've got a firework exploding. That's a series of super fast, super energetic chemical reactions, releasing all that light and sound.
And the list just goes on and on. That apple slice that turns brown on the counter? That's a reaction with the oxygen in the air. Rust forming on an old iron chain? A very slow chemical reaction. Even the food you ate for lunch is being broken down right now by chemical reactions in your stomach. They're literally always happening, all around us, and even inside of us.
Okay, time for a little pop quiz. Let's see if you can put on your detective hat and apply what we've just learned. First question for you. Which of these is not a sign that a chemical reaction happened? The answer is A, a change in shape. Think about it. If you crush a can, you change its shape, but it's still aluminum, right? That's just a physical change. But forming a precipitate or a gas, that means something new has been made.
And question number 2. When we burned that magnesium strip, what was the biggest, most obvious piece of evidence that a reaction was going on? Yep, it was B, that release of brilliant light and intense heat. That huge release of energy is a classic sign of a chemical reaction.
So, if you take one thing away from this, it should be this. Chemical reactions are the universe's way of building new stuff. They take the basic building blocks of matter, shuffle them all around, and create totally new substances with brand new properties. They drive change everywhere, from a rusty gate to a brilliant star.
All right, to leave you with one final thought, I want you to look really closely at these two objects here. On the left, we've got an orange that's gone all moldy, and on the right, a plastic water bottle that's been crushed. Both of them have obviously changed.
But only one of these represents a true chemical change, where brand new substances have been created from the old ones. So, based on everything we've talked about, can you tell which one it is? And more importantly, can you explain why? Keep thinking about it, and keep an eye out for that everyday magic all around you.